All right, everyone, welcome. We're going to hear from David Stokes about MySQL. Of course, MySQL is actually one of our sponsors, along with MongoDB, Text Systems, Deseret Digital Media, and Automatic, who does WordPress. So go out, thank them in the hall. We're happy to have them. So take it away.
Make sure you thank the volunteers. They do this for love of the community. They spend a lot of time, effort, blood, sweat, and tears that you don't see to make everything look smooth. So if you think everything looks perfect and just flows perfectly, you're missing a lot of what they have to do behind the scenes. So please thank the volunteers. I am Dave Stokes. I am a community manager for MySQL. A little bit over 8 years ago, I was a happy MySQL AV employee when we got bought by Sun. And a couple of years after that, we got bought by Oracle. So now Oracle sends me out on the road. My job is to go out and evangelize MySQL products. This talk isn't so much about MySQL, it's some MySQL facets to it, but it's basically talking to developers about using SQL. I've been doing this job going on my 6th year now, and I talk to thousands of developers every year. And what's amazing, especially in the PHP community, you guys are on top of what's going on with PHP 7. You're great with 3 or 4 frameworks, including the one you yourself. JavaScript is no problem. And then I ask you about SQL, and I see the nervous look on your face. It's like, oh my God, don't ask me any more questions. So this is on database basics for programmers. All my talks are Oracle asked me to put in a safe harbor agreement. Basically, if I talk about a future product that's not actually shipping, take it with a grain of salt. Don't hold myself or Oracle to the details. Also, I have a limited number of these fuzzy little guys. If you ask questions before they run out, I will toss one at you. I like to encourage participation in the things. By the way, my arm is horrible and my aim is pretty bad, so if you're sitting in the back and ask a good question and I throw it, someone might snag it. So if you want to come down front to make sure I get it to you, please do so. Okay, MySQL, most popular database on the web, ubiquitous. I have 16 plus million instances. I heard 45 million the other day. I'm not quite sure what the actual count is. One probably does. Surprisingly, we feed 80% of the Hadoop farms out there. And we're now going on our 21st year, so we're no longer the bright, shiny technology. PHP. This is a PHP conference, so I won't labor you what's going on with PHP. Now the question I get, as I talk about MySQL being around for 20 years, is what have you done for us lately? Well, MySQL 5.7 came out this fall. If you want to see the complete list of changes out there, it's out at our website, ironically called completelistofeatures.com. Over 150 work logs on things, everything from native JSON data type, better security, better performance optimization, all that fun stuff. Most of you probably have heard PHP 7's out. David Shafik has a wonderful talk on it this week. Unfortunately, I think it's the same time as the show. It's this presentation. So, databases built on a relational model. I can probably make 3 or 4 people in this room blanch by saying the words relational calculus. The big trouble is there's a lot of fancy words that go out there that are fairly easy to explain to programmers and don't get frightened if the things sound nasty. Set theory. A lot of programmers around the world are not taught set theory, which I find amazing. I went to a series of universities and colleges that unfortunately I tend to get set theory all the time. So relational data has been around for decades. Most business models are built around it, lots of vendors, and the original goal was to store data efficiently. Back in the late 60s, if you were writing something to disk, you had to make sure you had the disk rotation all set up, you were writing at the sector level and all the other stuff. That's been gone for a long time. But the original goal is still stuck around, to store data efficiently. So, PHP, as you know, is 80% of the websites. SQL is still the main data store for a lot of folks. We can talk about NoSQL later and a lot of features of the NoSQL world. We're filtering in the SQL world and vice versa. The PHP community is very rich and vibrant. PHP itself is mainly a procedural language with a lot of object-oriented features on there. If you want to argue that, please contact Anthony Farrar. We can go through all that. MySQL, on the other side, is a declarative language. You describe what you want. PHP tend to build the infrastructure. SQL is more like ordering pizza. I want this size with this toppings and at this time. Now, trying to combine them is often difficult for a lot of folks. If you're into academic papers, there's a good gentleman at University of Texas who wrote a thing on something called impedance mismatch, which is a technical term for when you're trying to mix two things that aren't alike. So don't panic. Okay, a lot of developers don't really appreciate the behind-the-scenes work that goes on when you make a call to a database. What happens is you write the code that says, okay, connect to this database. In the MySQL world, the first thing that happens every time is the user is authenticated. So every connection you make, we have to figure out where they're coming from, what account they're using, what password they're using, and then what permissions they have to the data. Now, that's a small amount of overhead, but it's one of those things where you do it 10,000 times an hour, it adds up. MySQL permissions are rather promiscuous. If you want a shock, read through the man page on it. It tries, for ease of use, to let you in as soon as possible. So you can actually find out that your account, Joe at work IP address, has different permissions than Joe at home address. Usually you'll find this out because your boss is working from home trying to do performance reviews and he can't get to the data he needs. So once the permissions are checked, the server is going to check the syntax. Syntax errors are fairly easy to kick out. And then MySQL has to come up with a query plan. This is how do I get everything the person's requesting for and coalesce it to something I can send back. In Oracle and other databases, you can lock that down so once you figure out how the query is supposed to work, it works that way forever. MySQL wants to re-optimize that query every time, which is another layer of complexity. So once the query plan is produced and executed, we'll go into that in a little bit more detail later, the results are returned to the application, and then the connection is torn down. Believe it or not, if you take a database class from most of the vendors, this is probably going to be the first day and a half of class, talking about the procedures and the policies there. So what I've given you in the past 2 minutes, probably save you a day and a half. So once again, the application talks to the server. Quick coding example. Everyone here's a PHP coder, I take it? Okay. If you've never seen this type of code before, let me know. You create a connection using the MySQLi API. Do the connection. If you can't connect, you can spit out an error. By the way, be very careful when you spit out your errors. If you don't know why, catch a couple of people who are hurting right now, or myself later. You perform a query. In this case, we're selecting name and show size from users where a qualifier called active is equal to 1. And the second grouping of lines there is getting the query and reporting an error if there's a problem. At the end, you free the result set and close down the connection. You probably can all do this in your sleep. So, you're lucky in the PHP world. The documentation for connecting to databases is very, very well documented and very clear. And it's out there in, 17 languages right now? Other programming languages, Python and a few others, it's not as clear. By the way, I don't call Stack Overflow and Quora documentation. So if you're searching for answers and the first one that pops up on Google is Stack Overflow or Quora, and right below it's php.net, please go to the php.net. Right now there are two APIs. Both you can use procedurally or object-oriented. They are PDO, which is kind of a database generic way of doing things. The pluses there is that you can easily port from one database to another. The bad news is it's not as efficient as the MySQLi, which is written and supported by MySQL engineers at Oracle. There was a previous API called MySQL, which if you've been porting code from say like 5.1, 5.2 to anything later, it's probably been the bane of your existence. It's no longer supported, it's deprecated, do not use. If you see a piece of code, please rewrite it. A lot of code is out there still, so please take care of it, get rid of it. And plus, the best thing for PHP developers is there's millions of lines of examples out there on the internet. If you have a question, there's lots of examples on the php.net site. Your favorite framework. So, if all this is so simple, why do you all write queries that suck? First problem is SQL itself. The gentleman who came up with the idea for SQL, a man named Codd, C-O-D-D, who worked for IBM in the 50s, 60s, and 70s, was trying to figure out a way how to save data efficiently. That means the minimum number of redundancies, easy way to tie things from one table to another. So he came up with the idea of structured query language. In the early 70s, it was taught very heavily and then started tapering off. There's not a lot of good books out there in structured query language for the average developer. The language is kind of finicky, and being descriptive, it doesn't really match up to what you get taught in a procedural or object-oriented class. It's like going to Texas for the first time and having someone say, "Bless you, dear." Understanding their kind of result. Well, the good news is it's all built on set theory. You can also call it relational calculus if you're trying to impress someone at a bar. But basically it's set theory. And the big caveat is you cannot tell a bad query from a good query just by looking at one. PHP code, if you've been coding for 6 months, you open up a new package and you look at it and everything's not indented, the curly braces are not in places, you know it's not good code. And you're going to be distrustful running through PHP unit or something else to make sure it runs well. SQL, you really can't tell. Second problem, coders. You guys have a lot of demands on you. Also, you're usually taught to think as data in a single line or a single object. Often, you don't let the database do the heavy work. You're looking through the wrong end of the binoculars to try to make it work going. Also, recently, with the rise of NoSQL, is people don't really want to really analyze their data, they just want to store it. They're so anxious to get it on disk that they're really just making, instead of data warehouses, data landfills. They're throwing everything to the disk without breaking it up. Okay, 2 minutes on SQL. Once again, it's a descriptive language. You say what you want. I want all the records from this database sorted by this, where they're in this zip code. You describe the data you want to store. It's designed up, it's carved up into 2 parts. Data description language. Is it an integer? Is it a character? Is it an enum? It has this, is it nullable? I won't go over the concept of null if someone really wants to. Does it have a default value? Does it have a character set that's different than everything else in the database? And then there's data manipulation language. For most of you, that's where you're going to spend your time. This is where you use the data. This is where you select it. This is where you delete it. This is where you update. So here's an example query. Very simple one. We're saying we want to select 3 columns from a table called city. We're going to put a qualification on there, city where the population's over, what is that, 1 million? and then we're going to order it by the name. Fairly simple language. Have I thrown anyone with this query? Okay. So that's the data desired, where we're getting it from, the qualifier. Now here's a slightly more complex query. This is where I'll start hearing some eyes roll back in the back of your head. Here we're taking two tables. From a table called city, we're grabbing the name and the population. Very similar to the previous one. However, we're also going to get the country name from another table. So what we're doing is we're joining the two tables, and we're saying we're going to use these two column names that have been pre-set up to reference each other. And in this case, the country.code column is the same data as in the city.country code column. Someone has architected the data as the crossover point there. Still fairly simple? Haven't lost anybody? Now, those of you who remember Venn diagrams will recognize that we're looking for the nice little intersections between magenta and orange there. And where we're joining, we're using hopefully key or index columns on both tables. So we have the two tables joined up together. By the way, you folks know the only SQL joke out there, don't you? DBA goes into a bar, sees two tables, and asks, "May I join you?" Yeah. Yeah. SQL's not going for jokes. By the way, this is commonly known as a left join because we're taking the left hand of the Venn diagram and matching it to the other side. Believe it or not, if you take one of the big SQL classes at one of the popular East Coast universities, this is the first 6 weeks of the class. So, big recommendation. Go out to Google, put in SQL Venn diagram, find the color combination that's your favorite, print this out, stick it up on your wall. Why? If you're not used to doing database work all the time, and you're trying to figure out what your joint's going to look like, you have a nice diagram. Now, you're going to do stuff like on the top left or top right, 99% of the time. I've been doing databases for 24 years now, and I've only run that once in my career. So please print this out, and it'll save yourself a lot of time and effort. Okay, is the following a good query? Select city.name, country.name, city.population from city, join country on country.code equals city code. You open up PHP Storm, that pops up on your screen, and you look at that. Is that a good query? Anyone want to risk an answer for a dolphin?
No, it's not a good query.
Well, the trouble is, it might be good, it might be bad. Right now, you don't know. If you ever saw the movie Charlie Wilson's War, where they give the Zen paradox of time will tell, this is the same thing. We don't know if they're asking for the right information. Here's a more realistic query that you're going to find when you open up PHP Storm or Vim or Emacs. I know programmers will look at that, they ignore it, close it out, say, must be good, I'm not going to fuss with it because I don't know if that's going to help me or not. By the way, this is a good query. This is from one of our test database examples.
How do we know it's a good query?
You're going to have to take my... But I do know lots of folks who look at that and they'll just, someone else's problem, I'm not going to touch it, I'm just going to assume it's good. So, do you have the right column names? Oftentimes, when I look at other people's projects, I see they have the same data twice in the same table because they needed to express it in a slightly different way. Is the city name, is it the official USPS name for the city? Is it the 3-letter abbreviation for the city, for an airport code? Unfortunately, you gotta dive into the data. Are the keys correct? If you're not joining stuff from one table to another on the proper keys, it's mixing apples and oranges and ending up with a banana that tastes like a pear. It doesn't quite work. Are the units correct? On the previous example, is the population counting in ones, thousands, 10,000s, millions? NASA had a problem several years ago. Half their team that was engineering a machine to go off into the universe was using 3-digit rounding. The other side was using 4-digit rounding. Not a big difference? Well, we go over several million miles, it gets bigger and bigger. The other problem is one was using inches and the other one was using meters. So unfortunately, you gotta check the data. Also, can you use an index to get to the data? Without an index, you have to read the entire table because you don't know what's in there. With an index, you go right to the particular record or records that you want to go to. So, once again, what does the server do when it gets a query? Once again, can this user talk to me? Is there a host? Yes, sir.
I was going to ask, what kind of indexing do you do? Like, what's your rule of thumb for indexing? When to do it? How often to do it?
General rule of thumb, if it's going to end up on the right-hand side of a where clause, index it.
Okay, good to know.
I can talk about indexing multiple columns in a little bit. The trick is, without indexes, it takes a lot of time to get to your data. With an index, you can go right to there. I have a better example of that later. So, as I said earlier, we check the query syntax. Have you fat-fingered something? That's usually not the case. Once again, does the user have the permission to get to all the objects you're talking to? With MySQL, you can lock down the permissions to server level, table level, or column level. And sometimes you don't have the rights to read that one column, and we'll get kicked out. Then, optimize our sphere, what's the most efficient way to get there? Execute it, return the data. So remember this query from the recent past? If you run it through an optimizer trace with MySQL, it shows you what it's doing through and doing cost estimates. Now, in the past, cost has been based on reading something off disk and into memory. In the old days, in the 70s, that was the most expensive thing you can do. Well, unfortunately for you guys, that's now become a variable. If you're reading something out of a solid-state disk or off a Fusion IO card, that's a lot different actual cost than actually pulling something off something that's spinning at 4,500 RPM on your backplane, or hanging off your backplane. So MySQL and all the other vendors are trying to figure out how to do variable costs. Now, you don't have to worry about that right now. 2 years from now, it might be easier to reassess your hardware and move your data around and put it on a faster thing. You can say something you're doing all the time. By the way, if you talk to the hardware vendors and you say, okay, in the 5 years from now, when I'm applying my budget, are there going to be a lot of memory thingies, a lot of spinny thingies, a lot of hybrid thingies? And they say yes to all those. We don't know what's going to be popular, but plan on all that. So this one, you're going to see how it goes out and examines the number of rows it needs to figure out where the data is. It has to read a sample of the data. It has to dive in there, so it's going there. And the cost, relative cost of going out there and reading it, the evaluation, and the number of data that has to be read per join. As a programmer, you don't have to know any of this. But if you keep in the back of your mind some distant shadow that the optimizer is trying to do all this for you, give you a better appreciation of what's going on behind the scenes.
Where can you get are you able to see the cost easily? Is there a program out there that you can use, or how can you get a lot of this? If you're running a query and you wanted to see if one was more efficient than the other,
Okay. Efficiency of queries. In the past, what you did is you took your SQL statement, went to the command line, and before you put it in the statement, you put in the word explain. In the past, for MySQL, it was only for select statements. So if you're doing a delete, you had to change the delete to select. Now MySQL supports all the other DDL or DML statements. So what you do is you type an explain before that query. That would come back and tell you, you're looking at two tables. Simple joins, which means they're straightforward. We're doing here on the top line the country table. Remember the query has city first? Well, the optimizer flips it around and figure out going to do that. It's going to use a primary key, and it's going to have to examine 239 rows to get the data that you want. Figure out how to get that data. Also on the second line, another simple select. On the table city, we're doing a reference count, which we'll go into a little bit later. And we have a possible key of country code, and we're using the key country code. There's lots of keys out there that are possible, and we'll list them all for you. The key length is 3. By the way, try to keep your keys as small as possible. Things moving from disk into memory and all that. Going from 3 bytes to 2 bytes, or the more bytes you have to move around in memory, the more it costs you. We're doing the reference on the 2 columns, and we're going to have to read 17 rows. Yes, sir?
So on that key, you said that the shortest possible. Is it more of a usability thing where you have a key that has text or just an ID?
It's more moving stuff around in memory. The smaller it is, the better.
So are IDs better than vectors?
The big trouble is it depends on your data. Each case is uniquely different. I have customers have GUIDs for everyone's IDs, and they're just looking for zip code. This is a lot bigger than this in memory, and when you're loading tens of thousands of these every minute, it's a lot easier to handle than changes. So on the other hand,
So, question, on that previous slide, you had a cost. Are those in cycle units, second units, nanoseconds? What is the unit of measurement I know what that cost is?
disk I/O for now.
Thank you.
Whether it's really going to be a true disk, that will change in the future. Now, I'm a dinosaur. I grew up on command lines. I grew up on touch cards. I used to see this. Fortran on punch cards. Yeah. Now, with MySQL Workbench, we have something called Visual Explain. It takes the information from the optimizer trace and will draw this pretty picture for you. By the way, this is great for documentation. You all know the word documentation, right? So you can lie to your management. What this tells us is we have to read everything in the country table, all 239 rows, and it's going to cost us 53.8 units on average, and then do a loop with the city table using the country code key for a total cost of that 5,078. The entire query is going to cost 5,132.14 units of disk I/O. I don't know about you guys, but after a couple hours of terminal, I don't think I'd rather read this. I'd rather read that. If you disagree, you can, but I think that's better and it's more easily conceptualized by a lot of novice programmers. Now I can jump from that previous one to this one, and unless you're under-caffeinated this morning, 80% of you in here will probably tell me what's going on here. Now, a very bad word. Actually, it's a very good query. It just looks messy. So each column in an SQL statement adds an additional factorial to the complexity of the query. So if you have one column you're looking for, the optimizer has to figure out one way to get to it. 2 has to figure out 2. 3 has to figure out 6 ways to get to the data, or the 6 paths we could possibly take. The optimizer is like a GPS. It knows you want to get from here to there, and it looks at the various routes to get there. Now, if you're not doing normal statistical updates on your database, I'll talk about that offline, you're using a GPS that doesn't know that this bridge is gone and there's a new bypass over here. So you have to do maintenance on your tables. Now, this is where the meat of the talk comes into. Iteration versus sets. If you've taken a programming class or sat down with someone's intro to programming book, you've seen the stuff on the left. And it does do the stuff on the right. Now what happens is when you do iterations, you end up doing something called the n+1 problem. Anyone here dealt with the n+1 before? Okay, the basic idea is you want to list your coworkers who live near you and have a car. You're looking for a ride to work. If you're a typical programmer, you're going to do something where you select all the employees, and then you're going to select the ones that are in your zip code, and then somehow you're going to select the ones that have a car. Doesn't matter if they have a seat for you or not, it's just the way a lot of programmers would approach this problem. Now, DBA, using a set example, would want to do 1 dive into the database versus 3. They're going to go up there and they're going to select the employees that live near you and have a car. So it's 1 dive into the database versus 3. When you hear the n+1 problem, we're talking about multiple dives into the database when you only really need 1. I like to call this the dump truck versus pickup truck problem. Your DBA, if you have a DBA, would be happy to give you more training in this. The idea is you want to take all the data in one load rather than backing up your F-150 and getting all the gravel you ordered and taking it in pieces. What the database do the heavy lifting? Databases are designed to get big sets of data. They're designed to sort big sets of data. Oftentimes they'll run into a software project and the developer grabs the data and then uses some internal mechanism in their code to do a sort. Inefficient. Also, if you're doing statistical functions on the data, unless you're doing some very weird Poisson distribution scheming, let the database do all the statistical functions for you. Your application should be a scalpel, not a machete. If you don't understand that, I have some property I have to get cleared out and I can show you differences. Also, only select the columns you need, not all columns. A lot of untrained programmers see the shorthand of select star from a table using the wildcard to grab all the data. If you need 3 columns from a 3-column table, works great. If you need 3 columns from a 500-column wide table, you're wasting time, you're wasting space, and you're wasting bandwidth. So think data, not language. Okay, what do I mean by heavy lifting? Your boss comes to you and says, hey, the guys in sales had a great year last year, we're going to give them a 20% raise. Put that into PHP. Okay? So you write something like on the left. Fairly straightforward, right? On the other side, the DBA would do something like that. They both basically do the same work. Well, what's the big difference? Well, the DBA would wrap that all in one transaction. A transaction is everything gets handled as one complete set. If something fails, everything's reversed out. If something goes wrong, your server crashes in the middle of the pay raise, which one of these would unroll easily? Which one could you recover from? Which one of those in the middle of it, the boss goes, hey, we found out the sales guys oversold, didn't quite get the books right, didn't do the accounting right. So that update you're doing right now, stop it and roll back to where they were. You probably can't do that with your PHP code. Transactions are the major place for most folks who are doing financial data, where the database can do the heavy lifting for you. Give it the workload, not your program. Also, you have to architect your data. What's interesting in a lot of the NoSQL world, they're now beginning to go back and say, you know, schemaless is great. Learn to normalize your data. If you have data that you need to denormalize, because you need to get over a hurdle or something like that, be advised it will probably, most likely, bite you in the butt later. The new programmer you hire 6 months down the road doesn't know the data is in 2 different places and only updates one set of the data. I've been a program manager 3 times where that's happened. It hurts. Also, if you normalize your data and keep to it, it saves you time, it saves you dollars, and it saves you sanity. The older you get, the more you realize that your sanity is slipping away and you'd rather have it rather than getting over the hurdle. Also use good naming conventions and be consistent about them. Custom_ID. Customer ID, custom ID. Try to spell out where you can. Also, once again, use the smallest practical data size. Very tempting to make your customer ID a big int. You aren't going to have 18 trillion customers. If you didn't win the Powerball last night, probably not going to have 18 trillion customers. The other thing is, you got to think about the worst case with your data. It's out on a platter or on some sort of device that the system hasn't been talking to in a while, so the data is old. And it's going to warm up that device, whatever it has to do, pull it off disk, maybe over a WAN, move it into a buffer, stick it in memory, and then make it available. Figure out the worst case data path, and the less you have to move, the smaller your data, the better. Okay, indexes. Promise a little more on indexes. My general rule of thumb is anything on the right-hand side of the where clause. So you're selecting food, comma, bar from table where, and all those column names, index those. If you're using NODB storage engine, please be using NODB. It will assign an index for you on a table if you don't give one. By the way, it won't pick the one you really want. Compound indexes for common combinations. If you have an index on year, month, day, that same index works for year, month, day, year, month, and year searches. So you have one index you can use 3 times. Unfortunately, that same index won't work for a day or month, day. Yes, sir?
So what would happen if you indexed all the columns in your table? Why is that a bad thing?
Bad problem is every time you write the data, or you manipulate the data that touches that index, there's overhead. Oh, this value of the index has changed, or there's a new index value that has to be inserted. The overhead just drives you nuts. I've seen software projects where they do that. It's not a good idea just from the overhead. Now, if you want to check out what's going on, MySQL 5.6 and 5.7 have something called a sys schema. And there's actually a way of going through the internal tables to go through and say, this index has not been used.
Can you repeat that again for me?
Within MySQL 5.6 and 5.7, there's now something called the sys schema. One of the things within sys schema, which is a set of views and routines that are set up for you by one of our engineers named Mark Leith, will tell you which indexes are not being used. The good news is it will tell you what indexes aren't being used. The bad news is you'll try to run it after you reboot your server and you don't have enough activity out there, so there's not enough good data, and it'll tell you, hey, all these indexes you can get rid of. So, yes, sir?
Is there a way to know which ones you should have? That would be cool too.
Yes. If you're using explain, it will tell you which indexes it's using, and it will also tell you it's not using an index.
Okay, not just generally
Yeah.
back in.
Yeah. The other thing that happens is in applications like data warehousing, they don't use indexes. They figure they have to read everything anyway. Yes, sir.
So these compound indexes, if you rearrange the columns, is it always the first column? So like in this case, you have year, month, day. If you had day, month, year, day would always be indexable.
Yeah.
Okay.
Whenever I call up my doctor, the first thing they want to know is my last name and my birth date. So I'm guessing they're indexing my last name and birth date. Hopefully there's not too many folks with my last name born on March 21st. Otherwise, I'm sure the screen pops up and gives some indication. Any other? One of these days I gotta do a talk on indexing. It's one of those esoteric things for DBAs that drive programmers up the wall. There's some hints up there I should get out to the public. If you want to learn how to do things better, the book on the left talks specifically about optimizing MySQL queries. It's about 120 pages long. Amazon runs specials on it every so often. It's written by a gentleman named Ronald Bradford. No fluff in that book, very straightforward. There are other books out there that are much thicker but don't get to the heart of the project or the problem. And it's a very easy read book. I highly recommend it. The one on the right, if you have to buy one of the two books, please buy the one on the right. SQL Anti-Patterns by Bill Carlin. He talks about how to architect your data, how to write queries to do what you want it to do. Also, that's usually on sale if you have a Kindle at least twice a month. Very good books. I do recommend buying the paper versions because you're going to want to stick notes in there and sticky notes and post-it notes and all this stuff. Both very valuable. So you listen to me and you go, I think I'm going to go with an ORM. Get rid of all that BS. Let somebody else handle it too. Well, you're adding another layer of complexity to your program. Also, ORMs, unless you explicitly tell it to prefetch data, is going to give you the n+1 problem. So, you have something else that you have to maintain that you another.
Okay, I don't know what ORM means, so what's ORM?
Object relational mapper.
Thank you.
You basically define an object, it goes out and does the voodoo to make sure the database does what you want. I'm sorry, I should have said
Isn't that compared to like PDO?
that.
It feels like an abstraction in both ways. PDO got the same address as this.
Not really. PDO has its own problems when you try to go things that are generic. It tends not to doctrine, eloquent,
Yeah.
The ORM and things like PHP are wonderful, but there's another layer of complexity. You have a junior programmer you toss at it, they may or may not understand what's going on. Now, if you're writing good SQL from the beginning, it's straightforward and it's self-documenting. If you have an ORM, some changes in the ORM that you're not aware of. 2 years ago, I had a customer recover all their data after their ORM had a minor bug. So, I'm getting close on time. I had some minor code examples, very similar to the stuff I had earlier. By the way, if you're keeping things like username and passwords in your source files, know who can read those. You're less likely to be hacked from some teenager from North Korea trying to get into your stuff than some pissed off employee who knows just enough to get into your database and cause damage. Also, if you're doing connection errors, know where that's going. Write it to a log file, write it to some sort of named pipe to get answers back and make sure someone monitors it. Don't throw it up on the screen. I have some examples in PDO. By the way, I love PDO. I think my MySQL I is a little bit better. Use prepared statements. Why? You're moving less data back and forth, and it also screens some of your data. So if someone's trying to do some SQL injection, putting an SQL statement where you're expecting an address, it will block that for you. This is a nice little example. You use these question mark placeholders and then you bind the values to the placeholders, and off you go. When I'm doing a coding project for something in open source, this is the way I like to see things done when we're getting stuff to the database. To me, prepared statements are easier to read. A lot of studies out there saying they're more efficient. They help get rid of SQL injection attacks. And by the way, if you've never heard this, let me be the first to tell it to you. Never trust the data the customer gives you. Scrub it. I was talking to a bunch of Python programmers at Texas A&M last fall, and they never heard that. Here's yet another example. Pulling back the data. I'll pass it on. So, let's get into Q&A. What haven't I answered? What else do you need to know? And if you're interested but are too shy to speak to me, there's my email address and my Twitter handle. I also have a blog. The slides are out at slideshare.net/David M. Stokes. And I have a table out in the main room, and I'm here for the entire conference. I'm talking tomorrow on the new JSON data type within MySQL 5.7. So if you have any, yes, sir.
On the execution plan gets cached on prepared statements, so it's reused.
Yeah.
Whereas if you did a normal insert, it gets, every time you change your data, it's a different plan.
Yeah, but there are some caveats behind there. If something's changing underneath in the database, like someone's doing index maintenance, it might flush that out. So usually it makes things more efficient, not all the time. Yes, sir.
Can you talk just maybe briefly about when to use MyISAM and when to use InnoDB and like what character encoding to use?
Okay.
I know that's a loaded question, but
It's really not. ISAM is 1960s technology coded in 1970s style. Does not do transactions, does not recover well from crashes. Oracle's not putting a whole lot of money into MyISAM. InnoDB does ACID, does transactions, does all the stuff you want in a database, recovers nicely from crashes. Matter of fact, our new recommendation is replication information that you're sending to replicated slaves. Put that in an InnoDB table, because if the thing crashes, it knows how to rebuild itself, and you don't lose data. It's safe. Character sets. If you're a good old American, and you can get by with doing everything in Latin 1, you don't have to worry about umlauts or cedilles or anything like that. Do everything in Latin 1. Force everything in Latin 1. That doesn't work for you? UTF-8 MB4. Not UTF-8, but UTF-MB4. Make sure you get the full MB4.
What's the MB4?
It has a couple more graceful handlings for Unicode character sets than the shorter version, the UTF-8.
Because Latin 1 is a shorter set. UTF-8 is a lot more, you gotta have a lot more disk.
Yeah, and UTF-MB4
Is it a little more than that?
Yeah. If you're doing anything that requires some sort of fancy thing on hanging off the character, go UTF-MB4. By the way, if you're doing stuff in Mandarin Chinese, we're the only database right now that supports GB 18 of 30 character sets. So if you have to do that, use that character set. Was there another part to that question?
no, those are the 2 parts. Thank you.
Yes, sir.
Since Oracle owns MySQL, and I've got a guy at work who keeps trying to push us towards an Oracle database, when is a good rule of thumb to make that transition? When is not? How do I answer him in a valid way that's, is it worth it to move it, or can MySQL continue to handle what we've got?
I used to do a lot of outside consulting with multiple databases. I also deal with a lot of folks in the Oracle community. My unofficial answer as a consultant, not an Oracle employee, is when you have to do SEC 10J filings after your initial public offering, Oracle Fusion Middleware does that very well.
Okay.
So bring that in alongside your MySQL. If you're a ticket master, the front end is all MySQL, the financials are Oracle. If you're Sabre, anyone who flew here or flies, Sabre does millions of transactions a minute, and they're all a big Oracle shop. So until you're doing well north of 10 million transactions a minute, you can do it with MySQL.
Okay.
Yes, sir.
I have some questions about, is Oracle going to remain committed to MySQL? And are they trying to stay featured on par for features with like Mariah and some of the other options, the branches?
Ironically, they said to the European Court, we'll support MySQL for 5 years. We're now going on year 7.
Okay.
We're making money for Oracle. My bosses are happy with the numbers. We're the number 8 classroom class in Oracle overall. Oracle has 10,000 products, and each one of them has at least 3 classes, so that's amazing. We're like number 12 in the download the DVD class. Most folks who run big Oracle installations also run MySQL. MySQL is a much lighter footprint in most cases, so Oracle is very happy. We're one of about 12 databases that Oracle has. Are we going to feature with Oracle 12? No. We're backing into common table expressions and materialized views. That will probably be out in 5.8, 5.9. Will Oracle be supporting it? Yeah, we're making plans for 5.8 right now. So if you have any feedback, we send them blogs once you do. 5.9, we're looking at a lot of stuff that's going to be past a 2-year window that we want to put in 5.9. And then they're making noises about what we're going to do past 5.9. So my general answer is, I think the last 2 things that are going to be turned off in the last data center will be COBOL and MySQL. Actually, I think using COBOL consultant and getting big paychecks. It's very tempting when the government comes back and offers you a lot of money for code you haven't seen in 40 years and asks you to update it.
Thank you.
Yes, sir.
One thing we're running across more and more is like Mariah DB. Can you kind of expound on that, like difference between?
Okay, officially they want to be called Maria DB.
Or Maria?
Mine was Monty's first daughter. Maria was his second daughter. We named his company after daughters. He's out of daughters, so I think he's out of company. Monty was not happy when Sun took over. So he took his code and forked it. He especially was not happy when Oracle came in. Oracle had tried to buy MySQL several times before. So Monty put his stake in the ground and said, this is Maria, we're going to be antithesis to what Oracle's doing. He and his 20 group of core programmers have been there for a long time, and they write some very good code. Meanwhile, Oracle came in and looked at us and said, you're good, but you need help here. Go out and buy some engineers to do this. Go out and do this. Move it this way. Monty has a view of the open source community as the beginning and end for everything. Oracle has a much bigger horizon. Our developers have gone from roughly 55, 60 at the time of acquisition to well into the 170s right now. And we are hiring. If you know any C++ coders, give me the resume. We're also hiring a lot of Python coders for things like MySQL Fabric, which lets you set up fault tolerant, automatic failover server groups for high availability or sharding of data. So Oracle is pumping money into us like you wouldn't believe. And there's also Percona out there. There's some other forks in MySQL. Percona is out there. Percona has a good product. They put in a couple of little switches here and there to give some views and information they like to use when they're consulting. For the customer, it's a great world. But if you look at who's improving the product the most and moving things down the road and adding features, it's Oracle. Yes, sir.
What's the roadmap for analytic functions like window functions and things like that that Postgres has and Oracle has?
Windowing, we might see some of that creeping in with 5.8. I have a feeling, gut feeling, having done windowing with other databases, probably about 5.9, so 4.5 years down the road, hopefully. Some things you could do with cursors, I think you're going to see creep into 5.8, but right now we have 5.7 out since October, so we're trying to get things going. Well, I'm the last thing standing between you and lunch. So, if you have any other questions, please hit me up. Anyone left off?